So we've been talking about chapter 13. We've gone through sections 13.1 and parts of 13.2. Any questions from you guys? As Jack pointed out, there is the homework quiz today. Really covering things from 13.1, the first lecture. What do you guys got? You got anything that you want to talk about here? Ask about?
Yes.
Okay. Okay. Do you want to just pick one of these, any of them?
Yeah.
Whatever one's on the homework.
You want to do 4. Okay. So it says at most how many zeros could the function have and how many extrema could the function have. We don't need anything to do this other than our theorem here. So the degree for the polynomial will answer both questions. What's the degree for this polynomial? It's 9, right? So that means that we have 9 zeros. We have at most 9 zeros. And we have at most 8 extrema. That's it. Nothing more to do there. Keep in mind that when we say at most 9, that means there could be 9, 8, 7, 6, 5, 4, 3, 2, or 1, or 0 zeros, and 8, 7, 6, 5, 4, 3, 2, 1 extrema, but instead of listing all those possibilities, we'll just say at most, because it makes it a little bit easier. Less writing. Jack, you happy with that?
7. Told me to ask.
Okay. So 7 says describe the end behavior using the limits. So right away, if I look at the function here for 7, that's a polynomial, correct? So the polynomial function is only going to have 2 end behaviors. It's going to have the arrow at the left end of the graph and the arrow at the right end of the graph. So right away from that, I can write this piece and this piece. So we have the left end is represented by x going to negative infinity and the right end by x going to positive infinity. So far, so good. So that's just kind of the setup. I'm just going to then graph this. Oh, got to change my mode because I was doing something different in the other class. Okay. We'll type in this guy here, negative 5x to the 5th plus 7x squared plus 8x minus 3. I'm gonna do, I don't remember, I probably was goofing around with the window, so I'm just gonna do zoom standard to reset my window to like negative 10 to positive 10. Okay, so if I look at the left end of the graph, it's pointing up. So the one here with the negative infinity, since that's pointing up, it's pointing up towards positive infinity. And if I look at the right end of the graph, that's the piece with the positive infinity, that's pointing down towards negative infinity. That's it. So for you guys, if they're polynomials, the only 2 parts you're going to change are going to be the parts that are highlighted. The pieces in yellow is representing the left or right end of the graph. So whether it's positive infinity, that's the right end, or it's negative infinity, that's the left end. And then the part in blue is going to describe which way that end of the graph is pointing up or down, where up is positive infinity and down is negative infinity. So it's, again, got to know what the notation is saying, but it's like pretty easy to translate the picture into the notation. Is that okay? Oops, but we probably should have, this should be h of x here, huh? Because the function we have is named h of x. But otherwise, that's all. Jackie, you cool with that?
Yeah.
Cool. Again, super easy to do, but you got to know what like the symbols are saying there, right? But translating what you're seeing into symbols, not hard. Nope. Not yet. We're going to get there today.
How far did we go? How far is one go?
Well, the first homework assignment here was 1 through 8. That's what you guys did for Sunday. Or didn't do for Sunday. Some of us have yet to turn in a homework assignment for the semester. Which you might want to get on if you're in that camp. Okay. Yeah, because you can definitely do like an entire semester's of the homework in like 2 days.
If I just sit down and get some music on, I could like fly.
Okay, well,
Actually do that every
get your wings out. Get your wings out. All right. So, Rami, basically 1 through 8 is from the homework that was from section 13.1, which is what we're doing the homework quiz on. For Sunday, the homework is 9 through 12 and then 15 to 19.
To describe the end behavior, can I just write like as x approaches infinity, or you have to write?
Well, it says using limits in the direction.
Okay, so that's Li.
Yep. I mean, that's what you did last year. That's what he's asking is like, why do I have to use a different? And the reason is that we're going to use this limit notation kind of going forward to do some other stuff potentially, maybe not in this course, but in future courses. So it's just a nice soft introduction to it, where it's something you already kind of know how to do. It just kind of breaking this notation in a little bit rather than just like all of a sudden here's some new notation when you're expecting to do hard stuff with it that you don't know how to do. It just becomes like, can you use this notation kind of question? You know what I mean, Ram?
Yes, sir.
Okay. Anybody else with questions from the homeworks?
So those two kinds of questions are the only ones that are going to be on homework quiz?
Well, the homework quiz can cover section 13.1. So the homework associated with that was 1 through 8.
Wait, real quick. Which one goes with the zeros and which one goes with the extreme? I forgot.
The X.
They both have to do.
I got it. I know how to find it. I was just making sure I did it right.
Zeros are the same as the degree. Extrema is 1 minus the degree. Okay. Don't let Landon intimidate you with his weird voice he's making here. Like he's a cartoon character. Sounds like Patrick the Starfish or something. I don't know if that makes you SpongeBob or what, but it could be worse, right? All right. Cool. So if everybody's...
Oh, can you just do 1 or 2?
Yeah, sure. So 1 and 2 are pure calculator questions. So let's just say for the sake of argument we do number 1. I'm just going to go to the y equals on my calculator, type in my function, hit graph because I know I'm already over that the window we had from before, right, from -10 to +10, so it's probably sensible. So I'm looking for the zeros. That's 1, 2, 3 x-intercepts. And then the extreme, I have 1 local maximum here and 1 local minimum down here. So those are the 3 points, or 5 points I need to find, the 3 zeros, the 1 local max and the 1 local min. To do that, I'm going to be pressing second and trace. I'm going to use the commands from this calculate menu. I'll use the 0 command to find the zeros, use the minimum command to find the minimum, and the maximum command to find the maximum. Cool with that? We did do this last year. All 3 of these commands work the same way on your calculator. So let's just say I want to find the zeros first. The calculator is going to ask me 3 questions. So let's say we're looking for this 0 right here. So the first thing it asks for is a left bound. See at the bottom it says left bound with a question mark. So it wants me to pick a point on the left side of that 0. So I'm just going to move my cursor to the left. Anywhere on the left side is fine. So I'll just press enter here. Then it asks for a right bound. So I'll just move my cursor so it's on the right side. Press enter, and then it asks for a guess. The guess doesn't matter as long as there's only 1 0 in between your 2 bounds, which I don't know why you would do it any other way. And there it spits out -3, 0 is my 0. Easy. Right, I would do that 2 more times for the other places. I'm not going to do that, though, in the interest of time. Is that okay?
Yeah.
And then to do like the min and the max, same idea. I press second, trace. Let's say I want to find the maximum this time. So it's going to ask me the same 3 questions, left bound, right bound, and guess. So my max is up here. That's on the left side, so I'll press enter. Move my cursor so it's on the right side somewhere. There we go. Press enter. Guess doesn't matter as long as there's only 1 in between. And then at the bottom of the screen, it spits out the maximum. So -1.732052, 10.392305. Easy peasy, right? Nothing really to do other than use your calculator and remember some definitions and stuff. A little bit of notation. Nothing complicated though, right? Unless you think the calculator's complicated. But the calculator's doing all the heavy lifting for you, which is nice of it. Say thank you, calculator. Yeah, you've assured me you do have a calculator. I've yet to see evidence of this though.
It's blue. So I don't know where it is.
Okay. Yeah, when it's time, I have extras. I have 4 though. I have finitely many extras for those of you that are habitual calculator borrowers. That's a mistake. You should have gotten collateral. Should have been like, give me your wallet and I'll loan you my calculator. Because I know you're not leaving school. Or give me your car keys. Because I know you can't leave school without your car keys. So you got to find me before you can, to give me this calculator back before you can leave school. That's a good method. All right. Well, let's return and pick up where we left off here in section 3.2. Or 13.2, excuse me.
To be last.
Yeah, I typically do it at the end because then it's only 1 transition. I don't have to like, okay, put everything away. Do the homework quiz. Wait for everybody to get done. Now take everything back out. You know, it just like wastes time. This way, it's just like, we do the lecture, everybody's already got everything out. We finish. You do take the homework quiz. When you're done, you're done. You can work on some other homework or whatever, or twiddle your thumbs or whatevs. Okay. So what we had been talking about to this point was polynomial division, right? Last time we had talked about polynomial division. Does that ring a bell? So let's do another example of that here right quick. So let's say we have 2x squared minus 5x plus 4 divided by x minus 2. So how do we set up our polynomial division?
X minus 2 goes on the outside.
Great. So x minus 2 goes on the outside of the division thingy. And then 2x squared minus 5x plus 4 goes on the inside of the division thingy. Okay. Then what? We look at the leading terms and we ask what times the leading term of the divisor, x, gives us the leading term of the dividend, 2x squared. 2x. So I'll put that there. And I'll multiply to the entire divisor. And I'm going to write the result underneath. So far, so good. We then subtract down. Now, Mr. Kulik's recommendation is, rather than thinking about this as a subtraction problem, to distribute the negative through and think about it as an addition problem, because it's real easy to forget to distribute the negative through if you don't actively do it. So we have a negative 2x squared now and a positive 4x. When I add down 2x squared plus negative 2x squared cancel out. Negative 5x plus 4x becomes negative 1x. And then I'll bring my 4 down. And now we go back to the top. What times the leading coefficient of the divisor gives us the new, what times the leading term of the divisor gives us the new leading term of the dividend? In this case, negative x. What's the answer there? Negative 1. So we do the same thing now. We multiply to the entire divisor. We write it underneath. Subtract down. But remember, we don't, Mr. Kulik doesn't like to do the subtraction, so he's going to distribute things through. So that becomes addition, and that becomes a negative. So negative x plus x cancel out. 4 plus negative 2 becomes positive 2. So that's my remainder. Everybody cool with that? And I know that's a remainder because the degree of this is 0, and that's less than the degree of my divisor. That's my cue to tell me that I'm finished, is when the degree of whatever the dividend is currently is less than the degree of my divisor. I know I'm done. There's no more dividing that I can do. So what I do then, my way I'd write my final answer is I'd say, okay, 2x squared minus 5x plus 2 divided by x minus 2 is equal to my quotient, that's the piece on top of the division thingy, plus the remainder over the divisor. So this would be like the way I'd write my final answer. Okie dokie on that. Okay. Again, we did this last year, so it should look familiar. If you're not super refreshed on the details, that's okay. We do some practice in the homework to get us reacquainted with this, but this should be a skill that you recognize, like, hey, I remember at least doing this if I can't do it perfectly. But it's like I've done this before. Okay. So we're going to introduce now a series of theorems that are going to help us update this process. So the first is the remainder theorem, and that says that if a polynomial f of x is divided by a monic polynomial that means something of the form x minus k, where the degree is 1 and the leading coefficient is 1. Then the remainder is f of k. So let's look at what that's really saying here. So if I have, in this case, my f of x is 2x squared minus 5x plus 4. That's what we did in our previous example. And our x minus k is just x minus 2. Everybody's good with that? So if we do f of 2, that means we should plug 2 in for x. So what happens when we do that? We get 8 minus 10 plus 4. That is 2. So what we're seeing is that f of 2 gave me the remainder, or f of k is giving me the remainder. Is everybody okay with that? Now, if all we cared about was the remainder, which one of those two processes were easier to get the remainder from? Polynomial division or like plugging something into the function and evaluating? Plugging it in, right? In fact, you could just type all that crap in your calculator and it just spits it out for you, right? Considerably easier. Okay, good to know. Oops, this is the remainder theorem, excuse me. So now let's consider the factor theorem. So again, if we have a polynomial, actually, I'm not going to say, this is an if and only if. That's even better. So we'll say a polynomial, f of x, has a factor, x minus k, if and only if f of k is equal to 0. So why would that be true? Let's think about this numerically for a second, right? So let's say I asked you the question, is 2 a factor of 6? You would say yes, because 6 divided by 2 gives you 3 with 0 remainder, right? So the fact that when I divide the two numbers and I get a remainder of 0 tells me something's a factor. And if the remainder is the same thing as f of k, then I can just check to see if f of k is equal to 0. So let's consider the following example here. So let's say we ask, is x plus 3 a factor of 6x cubed plus 25x squared plus 16x minus 15? Well, what we can do, one way we could do this is to do the polynomial division. So we set this up the same way we just did. So I ask myself, what times x gives me 6x cubed? So that would be 6x squared. I multiply that to both places and then subtract down. Gives me 7x squared, and then I bring the rest of it down. Then I ask myself, what times x gives me 7x squared? Well, the answer there would be 7x. Again, multiply that to both parts. So 7x squared plus 21x. Subtract down. Gives me negative 5x minus 15. And then I ask, what times x gives me negative 5x? Well, that's negative 5. I multiply that through, and I get remainder 0. So what we can say then is that 6x cubed plus 25x squared plus 16x minus 15 divided by x plus 3 is equal to 6x squared plus 7x minus 5. And then if we multiply both sides by x plus 3, what we can say is that our numerator factors into 6x squared plus 7x minus 5 plus 3. Is everybody okay with that? Just like if we say, okay, is 2 a factor of 6? Sure, because 6 divided by 2 is 3. Or I could say, in other words, 6 is the same thing as 2 times 3. Right? Same idea. The alternative way of approaching this, though, would be to use those combination of would be to use remainder theorem here, right? So in this case, my f of x is 6x cubed plus 25x squared plus 16x minus 15. And my x minus k is x plus 3. So all I really need to do is evaluate f of negative 3 and see if that gives me 0 or not. Yes, sir.
Guys, restaurant.
Yes, sir.
Thank you.
Yes, sir. All right, so let's see. So we have negative 27 times 6. That's 180 minus 18, well, negative 162. 225, or 25 times 9 is 225. Or 16 times negative 3 is negative 48. And then minus 15. So negative 162 and negative 48 is negative 210. And then negative 15 is negative 225. And then plus 225 does indeed give me 0. So we can say, since f of negative 3 equals 0, x plus 3 is a factor of 6x cubed plus 25x squared plus 16x minus 15. Now, if I compare those two methods on the left and the right, which one was easier to do? The one on the right. Which one gives us more information, though? The one on the left. The one on the left not only tells me x plus 3 is a factor, but it also tells me what the other factor is, which is potentially quite useful. What we'd like to do is marry these two methods together so that we can do something that's easier than the long division, but also still get the other factor that goes with it. Okay with that? The answer here is going to be is hopefully what you remember, synthetic division. Hopefully this rings a bell. I want to point out to you that this synthetic division method we're talking about here today is the main method we'll be using going forward. You will need to be able to do this. You'll need to be able to do it quickly and effectively and accurately. Almost everything we do from this point forward in terms of factoring and solving and finding zeros is going to be relying on this synthetic division method, so it is a must-have from this point forward. Okay? All right. So let's do the same situation where we ask 6x cubed plus 225x squared plus 16x minus 15 divided by x plus 3. We're going to do this as synthetic division. So my setup is I start by drawing this thingy here. I put my value for k on the outside. So there's my value for k. Good with that. And then, and then I want the coefficients for f of x. Those go up here. Everybody's okay with that? What thing do we have to be careful about when we write down those coefficients for x or for f of x? Notice here in our f of x we have x cubes, then we have x squareds, then we have x's, then we have constants. We don't skip any degrees in our polynomial, so there's no problem. What if we did have a skip degree? We have to remember to put a 0 there, or everything gets all mucked up and it just is wrong. So there's no recovering from this like you could in synthetic division if you have a skip degree and you don't put a 0 in there. As long as you line everything up right, you'll be okay. Here, if you don't put the 0 in, no recovery possible. It will be wrong. Just being very clear. Okay. All right. So this is the setup. From here, the first step is always to take that first coefficient for f of x and just bring it down below. And then we just start our algorithm. So we start by multiplying that number on the outside to the number on bottom. We take that answer and we put it in the next spot. And then we add down. And then we just repeat that process over and over again until we've run out of, or we filled all the spots. Everybody's okay there? What we're interested in here is the last number, since that last number represents the remainder. We have a 0 remainder there, which is what we're hoping for. The next one is the constant term, i.e. the piece with degree 0. The next is our coefficient on x. Next is the coefficient on x squared, and they just keep going up 1 degree as you move from right to left until you've assigned each number as a coefficient to one term in your polynomial. So notice this was pretty much as easy as the substitution was. You're getting the information about what you get when you do the substitution, but as a bonus, you're getting the other polynomial as well. So really what we're getting out of this is that 6x cubed plus 25x squared plus 16x minus 15 over x plus 3 is equal to 6x squared plus 7x minus 5, or in other words, if I multiply both sides by the x plus 3, we get the same thing we did before, but I would argue this process is considerably quicker than the polynomial long division. I think it's less tedious. There's less places to go wrong. There's less like making sure I distribute negatives and I copy things down correctly. It takes up much less space on a sheet of paper. Overall, I think it's a more efficient method that gives us all the same information, but faster.
So it's the exact same way that we did last.
Exactly the same as what you did last year. Very good. Agreed. Okay. I have one other thing I want to talk about. Specifically, this is going to be how we do 13 and 14 from the homework. So let's say we want to write a polynomial with the zeros of, I don't know, let's say 1, 2, and negative 3 or something. Okay. Since I know that these are zeros, I know that when I plug those into my function, to some function f of x, that those should give me 0. Correct? From the factor theorem, I know that this means that x minus 1 is a factor. This one tells me x minus 2 is a factor. And this one says x plus 3 is a factor. Everybody's okay with that? So my polynomial that has these zeros would just be the product of those. Everybody's okay with that? And then you just FOIL that out. Right? I don't need to do foiling, do I? We remember how to do FOIL? And that's as far as I want to get to today. That should allow you guys to do numbers 13 through 14. And we should be able to do, 20 to 20, What did we do before? We went up to 19 before? Yeah, we go all the way to 31 then, I guess. 20 to 31. But this isn't due on the, what is it, the 13th or something? Not this Sunday, but next Sunday. I think that's the 13th. This Sunday's the 13th? Oh, so the 20th then? Sorry. So the 9 through 12 and 15 to 19. Unclear at this point, to be honest with you. We have altered schedules every day. So I think that the class times are like an hour the first days and then like the first 2 days, and then I have it here.
55 minutes.
Yeah. So we have like 65 and then 55 classes. So we'll probably not next week because I don't think we'll finish and have a review day in 2 55-minute or 2 like hour or less classes, in addition to the distractions going on, because there's still a little bit of complicated stuff left to do here. So probably not next week. It'll probably be the week after, which I'm sure you're devastated by.
I'm pretty upset.
I know. Just try to keep it together, though, guys.
I really want to test the
I know you did, but sometimes it just, you can, wish in one hand and poop in the other and see which one fills up first.
I got the Irish spirit flowing through me. I want to take a nap. Yeah.
I'm gonna start using